Hello, in this video I'm going to show how to solve a law of cosines problem without using the law of cosines, and then using the law of cosines and showing how much easier it is if you have it memorized. But it is still possible to solve it if you don't have it memorized. So right now we have this triangle that has a side of 50 here, a side of 20 here, a side of 60 here, and an angle of theta, and the angle of theta is what we're trying to solve. To solve this without using the law of cosines, I'm going to create two 45-degree angles and then solve it this way. Basically, I'll create these new sides, which this will be A, this will be B, and this will be E. So then I can manipulate them to eventually solve the problem. So we know that 60 is equal to A plus B. So that's one thing we know. And then we can also say cosine of theta is equal to A over 50 because cosine is just adjacent over hypotenuse. So it's going to be cosine A over 50, and then we can solve for A by multiplying each side by 50. So we get 50 times cosine of theta, and then we can do the same thing for B. We can say sine of theta is equal to, or same thing for E, I mean. Sine of theta is equal to opposite over hypotenuse, and we can see E is opposite, and the hypotenuse is 50. So we can multiply both sides by 50, and we get E is equal to 50 times sine of theta. Now we can also use the Pythagorean theorem on this side, where we can see there's an E here, a B here, and a 20 here. And since we have the right angle here, we can say E squared plus B squared is equal to 20 squared, which we know is 400. And now we can substitute in the values that we have. We know that E squared, we know that E is equal to 50 times sine of theta. So we can plug that in. I'll just move it over here. So 50 times sine of theta is squared plus B squared, which we can solve for A squared, since we need to solve this for theta. So let's get A squared, so then we can, on the next step, plug in A. So because 60 is equal to A plus B, we know that A is equal to, or B is equal to 60 minus A. So right now we can just say 60 minus A squared is equal to 400. And because we know A is 50 times cosine theta, we can get this so that the equation is in terms of theta, and then we can just solve off of that. So we can plug these values in. We can subtract A, which is 50 cosine theta. We can square that and set this equal to 400. Now we have the easy step. We just have to solve this equation. So 50 squared is just 2500. And then we can just multiply that by sine squared of theta. And then for this is just a square. So we can, it's in the form A squared minus 2AB plus B squared. So this 60 squared is 3600. And then 60 times 50 is 3000. Multiply that by 2. And then that's 6,000. And then also have the cosine of theta, because we have to multiply 2ab. And then we square b squared, which is this term. And 50 squared is just 2500. And we multiply that by cosine squared theta. And we set this equal to 400. From here, we can group the 2500 times sine squared plus 2500 cosine squared and group out the 2500, or distribute the 2500, I mean. So we can put the sine squared theta here plus cosine squared theta here. And this should be ringing some bells because sine squared plus cosine squared is just equal to 1. So on our next step, we'll be able to substitute that out. From here, we can simplify even more. We'll subtract 3,400 from both sides, and we'll get 3,200, and we'll add 6,000 cosine theta. So we were just working with even, we're not working with negative numbers. So this is 6,000 cosine of theta, And it looks like that's good. We'll move on to our next simplification step. We'll simplify this to 2500 plus 3200. Whoops, one too many zeros. Plus 3200, which I believe is just equal to, this is just equal to 5700. And then we set this equal to 6000 times cosine of theta. And then we can simplify from here. We'll just divide 6,000 from both sides. And then this simplifies to 57 over 60. And I believe we can actually do one more simplification. We can divide each side by 3, and we get 19 over 20 is equal to cosine of theta. Then we can find, I think it's called the inverse or arc cosine. Arc cosine of theta. We'll find arc cosine of 19 over 20 is equal to theta. We can solve this. I'll put this in my calculator. I'll do 19 divided by 20, and I get theta is equal to approximately 18.19 if we are rounding to the hundredths place. The other way we could have solved this problem is with using the law of cosines, which is just c squared equals a squared plus b squared minus 2ab cosine of big C, which is the angle for C. So we can define the angle and the sides here. So I put big C here as the angle because that's what we want to find. And then A is 50, and A and B don't really matter too much, but C does. So I assign 20 as C. So 20 squared is 400. A squared, I think we had A as 50, which is 2,500. And then we square B as well. And B is 60, which is 3,600. And then 2AB is 50 times 60, which is 3,000. And times 2 is 6,000. So, and then I'll multiply this by cosine of big C. So then let's simplify this. 2,500 plus 3,600 is 4,100, 6,100. And then let's subtract 400, which makes it 5,700. And then let's add 600 cosine of big C to both sides. So then this makes it a little bit more simpler. I think it was actually 6,000. I think I forgot a zero. So 6,000 cosine of big C. We'll divide 6,000 from both sides. And we'll do 5,700 over 6,000. And this simplifies to 57 over 60, which is also divisible by 3. And then this simplifies all the way down to 19 over 20. And then if we find the arc cosine of 19 over 20, we can do cosine -1 of 19 over 20 on our calculator, and we should find that we get the same answer. And yes, 18.2, 18.19 to be a little bit more exact. So that was somewhat of a quicker way, but both ways work. Either way works. This one's just a little bit faster. Thank you for watching.